Now we're going to talk about how resonance impacts acidity. And as per usual, we're going to be talking about this through the lens of the conjugate base. So anything that stabilizes the conjugate base makes the starting acid more acidic. It makes it a stronger acid. And how do we stabilize the conjugate base? Well, more delocalization of charge equals a more stable conjugate base. So more delocalization, more stable. So here we have two different OH bonds, and each of them can act as an acid under different conditions. But we're going to see how resonance has a large impact on one and doesn't impact the other. But to start off, we again need to draw the conjugate bases that are formed in these acid-base reactions. So the bases are deprotonating the acids. In the alcohol, it's getting deprotonated to the alkoxide, and we have BH in there. And the carboxylic acid here would be deprotonated to form the carboxylate. And it's very important that we're following all of our electrons, or we're counting them. To have that negative charge, we need 3 lone pairs, and then we have BH here as well. So now it appears at first glance that we have 2 molecules that are pretty much the same. We have a negative charge on an oxygen atom there, negative charge on an oxygen atom there, but overall it kind of looks like that entire negative charge is localized on one atom. Some of you that may have just seen the induction video might be thinking, well, in this case, oxygen is also pulling away inductively, and that's true, but that's actually a lesser effect than what we're going to talk about here as far as resonance goes. So I'm actually going to kind of spoil the ending right here by already telling you what the pKa's of these are. So the pKa of ethanol is about 16, whereas the pKa of acetic acid is about 5. So an enormous difference. So we have to remember each pKa unit, each one difference in pKa unit, so 5 versus 6, is a difference in 10 times the acidity. So we're talking over 10 to the 10th difference in acidity between these two. So why could that be? And it's not just because of induction. So when we see these molecules, this oxygen, the charge right there has nowhere to go, but there's another structure that we could draw of this carboxylate to really give a better full view of that molecule, and that's the resonance structure. So if we move the electrons here and move these electrons up to the oxygen atom, we have another structure that looks pretty much identical. This lone pair went down, so now this just has 2 lone pairs. This oxygen atom now has 3 lone pairs. And by drawing both of these resonance structures, we can see that the negative charge isn't localized on one oxygen atom here, but it's actually shared between both of the oxygen atoms, delocalizing that charge, making this a more stable conjugate base. So this is a more stable conjugate base. More stable because of the delocalization. So if it's more stable, then that tells us that this is more acidic, because if we have a weak conjugate base, that tells us that the starting acid is more acidic. And we can also draw the resonance hybrid to kind of further demonstrate that this charge is delocalized. So the resonance hybrid takes both of those into account, and that would look like this, where we have the oxygen atoms both have partial negative charges on them, and there's a partial double bond between both of those. But that just demonstrates this charge delocalization, making the conjugate base more stable. And again, we can look at the electrostatic potential map to further illustrate this concept, and comparing ethanol right here. There's ethanol where the the charge is fully focused, it's very red right on that oxygen atom, versus the acetate anion here is sharing the electron density between both of those oxygen atoms. It's a more orangish color instead of the redder color on this one, and you can see that it's delocalized over those two atoms. So that's how resonance impacts acidity. It stabilizes the conjugate base through through the delocalization of that charge. And I would point out that it's a larger effect than induction. It has a bigger impact on stabilizing the conjugate base, and you can see that in this enormous, drastic impact on those pKa values. Yeah, so resonance, really important.